Hi there! You're about to listen to a vintage episode of the Under the Microscope podcast. While the content is still as relevant and as interesting as when it was recorded, our webpage has changed. You can now find us at thesciencetalk.com/real-scientist-nano. Welcome to Under the Microscope. This series is brought to you by the Real Scientists Nano team. Our goal is to provide a platform where scientists can communicate their work and interact with the public. Hi everyone, today we have with us Johanna Jochum, who is an instrument scientist at the research neutron source Heinz Maier-Leibitz, close to Munich in Germany. Hi Johanna, how are you?
Hi, I'm good. How are you?
I'm good. Curious to hear about this research neutron source thingy that you work in and all kinds of things that you do. So let's start with understanding your research. So could you explain your research to us in super simple words, please?
So basically, I'm working at an instrument called Reseda. So Reseda is basically a very, very complicated machine with all sorts of very complex different parts, which you will hear about during my curation week. And basically what we do is we measure magnetic phenomena, well, mostly magnetic phenomena, and we measure the dynamics of these phenomena. For example, we did a very nice study in iron and see how the spins actually move close to the phase transition of iron from going from a paramagnet to a ferromagnet. And with this technique, you can really see where is the phase transition, how does the behavior of the spins change when going from being a ferromagnet, so everything is nicely aligned, to going to a paramagnet. On the other hand, we can look at superconductors where you have these vortex lattices where you have the magnetic field going through the superconductor and they move around. And we can also measure, for example, how do they move, how fast do they move, and what sort of time scales.
Wow.
And yeah, so we measure anything that moves in magnetic phenomena, but also in liquids, for example. You can measure the diffusion in water, for example.
Really?
Yes.
Oh
I mean, you can see how you have different diffusion things in water, like right, you have the water molecule that just like have this translational diffusion, so they just move along their paths. On the other hand, they also rotate a bit, and then the H molecules also kind of vibrate a bit, and you can look at all these motions.
Wow.
That's pretty cool.
That is really cool. So when you say that you can see it move, you can't see it as in visually, like not like an optical microscope.
No, it's not like a visual. We're just measuring how fast it moves. We cannot actually see it.
Okay, so then you can plot it with some curves where you can see that over this length, for example, this is how things are moving, and then you can quantify it. And can you also then make like a visual sort of a thing that this is how the water molecules or this is how the electrons are moving or something which is visual?
That's actually an interesting thing, because with the neutrons you don't actually see how the electrons move. We look at the atoms themselves.
Okay.
So we don't the neutrons don't really strongly interact with the electrons, but mostly with the cores of the atoms. Right. This is like this big difference that you have with like synchrotron light, where you have these high energy X-rays they mostly interact with the electron shell. So for X-rays, it's then very difficult to distinguish between two elements that are next to each other in the periodic table, because the outer shell looks very similar. Well, the neutrons, they really interact more with the core, because they're on the one hand heavier particles and they're not electrically charged, but they still have this magnetic spin. So they can really see more the difference between the atoms themselves and are not so much distracted by the electronic shell. So X-rays and neutrons are actually really nice complementary techniques, because you see very different aspects of your material.
Right. Good that you brought this up with the synchrotron because our current curator, Marjorie, she's working in Sweden at the Stockholm University, and university, yeah, I think so. And she is actually tweeting this week, and she's talking about she studies the amorphous ice, and she's basically understanding it with the X-ray radiation or synchrotrons or something like that. So yeah, that could be really interesting.
Yeah, definitely, because we actually also measured some spin ice systems at some point. So that we should definitely look at that.
Yeah,
We can do something together.
yeah, some collaboration happening right there. Awesome, awesome. Your research sounds super cool, super interesting, and there is a lot of things you're going to talk about. Also about Reseda. We are looking forward to meeting her. Um,
I decided it's a her since she's named after a flower, and flower, I think, in all languages are always female. So
right, let's go with that. Yes, absolutely.
plus, we are definitely underrepresented as girls in science. So
Very nice. Sneak it in. Absolutely.
yeah.
Yes. Absolutely. We have to talk about that. So, what can the followers expect in the week that you will be curating the Real San Nano Twitter account?
So I will start talking a bit about neutron scattering itself. I don't think anyone has talked about that before. I saw that there were some nice curators who talked about magnetism and superconductivity, which will definitely also be something that's going to come up.
Right.
But I will definitely focus on neutron scattering. Then what is a neutron scattering instrument? What parts do you have? Because I think this is something that people really don't know, because you cannot really, it's not like a microscope. You have this big thing standing here that is a very complicated machine, because this thing is like several meters long and has all these parts that you need to fix and keep going and make sure that everything works, right? And there's some really cool physics there in all these parts. So I will definitely introduce some of those. And then, of course, also talk about the science that we do and that we're planning on doing. And hopefully during the week of my curation, the reactor will start up, and then we will have like a live coverage of neutrons arriving at Reseda and
That's great.
Images of this experimental cycle.
Wow, that is really cool. Oh wow. Was there more? Sorry, I didn't want to interrupt you there.
You were not interrupting, it's fine.
Okay, awesome. So that sounds like a lot of things, and I really hope that the experiment is running when you're taking over the account, because I'd want to see the pictures and the live action happening there. So thank you very much, Johanna. This has been wonderful. Looking forward to having you on Real Scientist Nano.
I'm looking forward to.
Super.
Thank you for listening. To know more about us, please visit our website realscientistsnano.org and follow us on Twitter at realsci_nano.